Assalamu alaikum everyone. Welcome to Oil Gas YouTube channel, and this is our fourth lecture of porosity, permeability and saturation series. In this lecture we are going to discuss that how we can measure the grain volume of the reservoir rock core sample. But first we have to clear one thing, which is that when we extract a core sample from a reservoir rock, then we have to perform a number of laboratory experiments on that core sample, which may be at high pressure or low pressure as well. So when we are applying the various temperature and pressure condition on the core sample, then ultimately it will become damaged, and we have to perform a number of experiments on that core to measure various reservoir properties. So we cannot use only one core sample from to measure all the reservoir properties and for all the laboratory experiments. So what we do is that we extract a core sample, we extract a core from the reservoir rock which is larger in volume, which is very large in volume, and from that reservoir rock large sample we extract small core samples of regular geometrical shape. And I told you that usually these core samples are cylindrical in shape because of multiple reasons. We will discuss these reasons in further lectures. So we extract a large core volume from the reservoir rock, and then we divide this large core sample into smaller core samples, and then on these available core samples we apply the laboratory experiments to measure the reservoir properties. So the point which is necessary to clear was that we do not extract only one core sample. We extract a large single core sample and then we convert it into smaller core samples and apply the laboratory experiment on it, on these core samples, on these smaller core samples. And obviously these core samples are usually have volumes in some centimeter cubes. Their volumes may range from point something centimeter cube to 10, 12, 13 centimeter cube, depend upon the requirement of the experiment and the instrument that we are using. Okay, so this is the point which was necessary to clear. Now let's move to the point that how we can measure the grain volume of the rock sample. In order to measure the grain volume of the core sample, first of all we crush that core. We perform crushing on that core. The core whose grain volume is required to know. First of all it is crushed and then it is heated. Why we heated the core sample? We heat this core sample so that all the fluid which are present in the core sample is evaporated, and we can get the accurate reading of grain volume. So first of all we crushed the core sample, then we heated the core sample to remove all the fluids, and then we measure the mass by physical balance. This mass that we measure is basically the mass of grains of the core sample. That is, it is representing the grain mass. Now we know the grain mass of the rock sample, and since we know that the rock sample is made up of some definite mineral, let's suppose if the mineral is sandstone, if the core is extracted from a sandstone reservoir, then its major mineral is sandstone. The density of sandstone is known, that is 2.65 gram per centimeter cube. We know the mass of this grain of this grain sample in grams, and we know the density of the matrix of this core sample, and by simply dividing the value of density with mass, we can get the volume of grain volume of this rock sample. This is basically the grain volume. For this we are using the mass of grains of grains, and we are using the grains density. Let's suppose if the reservoir rock is limestone, then its density is also known and it is 2.71 gram per centimeter cube. If the reservoir rock sample is dolomite, then its density will be 2.87 gram per centimeter cube. These are the definite values of densities of various minerals of the rock. And we know the density of the rock mineral. We measured the mass of grain sample. By dividing the mass and density values, we can easily get a volume value which is representing the grain volume of the sample. In this way we can easily measure the grain volume of the sample. And since now we know the known bulk volume is known, we know the grain volume. So by using the formula phi is equals to Vb minus Vg upon Vb, we can easily obtain the porosity of this rock sample, of this core sample. And obviously the porosity value of this core sample is also the porosity value of our reservoir rock, because this core ultimately belongs to that reservoir rock. So in this way we can measure the grain volume. And in the previous lecture we discussed that how we can measure the bulk volume. Bulk volume and grain volume are known now, and then we can easily calculate the porosity value of the core sample or our reservoir rock sample.